is Dan Smith, Head of Technology at Perenti Group, and he'll talk more about simplifying migrations to Databricks Lakehouse. So welcome, Dan.
All right, thanks. Thank you, everyone. I appreciate, well, keep the round of applause going all the way through the speech. That'd be great. Thank you very much for joining me today. As Juan said, I'm the Head of Technology, Data and Analytics for Perenti Group. My name's Dan Smith. And I'm going to take you through our journey from what was a typical solution for a multi-faceted company like ours that came up from the 90s through the 2000s through acquisitions and how we migrated from that old data platform to a lakehouse. So before I talk about that, I want to walk you through what Perenti Group is and who we are. So we're a mining services company, a conglomerate of multiple companies. 4 of them are contract mining companies for underground and for surface. That's African Mining Services, AUMS, Ausdrill and Barminco. We also have a truck parts company called Better Truck Parts, BTP, and they supply fully built trucks or parts and repairs, not only to all of our sites, but also to our competitors. We have a logistics company, Supply Direct and Logistics Direct. That's 2 separate ones, and they help supply all of the incidentals to multiple parts of our businesses and to our competitors as well. And we've got Adobo, and I'll talk more about Adobo later on. They're a data science company, but they provide data consultancy services, not only internally, but to our competitors. So there's a lot of information flowing back and forward, and some of it's ours and some of it's not ours. But the biggest amount of information that we've got is definitely on our mine sites. So our contract mining runs 60 global projects, and we're in 10 countries. We've got 70 sites, so some of those projects have multiple sites, warehouses and those things on board. We're across 4 continents, and we have 9,000 plus employees worldwide. So it's a rather multifaceted business. As I said, most of our data lives in a typical mine site. So I don't know how many of you guys are in the mining industry or have had exposure to that. But here's an example of what might happen on site. We'll have trucking information, we'll have drilling information, we'll have check-in, check-out information, health and safety information in multiple systems. Those systems then send out and transfer information to each other on site. That data might also then need some third-party tools, like we have trucking and tie information that's kept in a SAS tool for one site and in an IaaS tool for another site. So those connections come in and out. We have to do site reporting, regional reporting, and then all of that data has to get brought together for global reporting. And this happens just on one site. The issue is compacted when we look at the 60 to 70 sites globally, right? So there's a lot of information moving around. Now, when we first got there, and I've been at Perenti for 2 years now, the architecture was basically built on replication. All of the data sources get replicated across the globe into one local data center, and then that data center pushes the information up to the cloud. The problem with that is we ran into all the normal things that you would expect. Network connectivity issues, comms issues. We run into that from the volume of data, and we also run into that because of the locations that we're in. So I'll give you an example of how mine sites are slightly different than you're running your average office. We went to commission a mine site out in Africa. This one specifically wasn't going to be with satellite comms, it was going to be fibre laid. We laid out the fibre, we went to switch it on, and nothing came through. So we called up the other end, some 100-odd kilometres away, and we said, guys, is it turned on your end? They said, yep, everything's working on our end. So they got on the truck and they started heading back, and the first junction box they got to, they opened it up, and it was filled with rats. They had eaten the fibre optic cable to bits. And they probably did that because it was like a little disco party in there for the rats. But once they got through that, they went, okay, we're going to have to order another one and repair that. But in Africa, it doesn't work that quickly. 6-week turnaround to get the part, get them out there, 2 guys to install it. They reinstalled it, put it back down, drove back and said, right, let's check it, see if it's working. Flicked it on, nothing coming through. Went back to the junction box, opened it up, filled with rats again. They chewed it out. So that's 2 examples of something that put the commissioning of a site's comms back nearly 12 weeks, right? They dealt with the rats this time, then they got a new piece and put it in there. So I bring that up because there's a lot of challenges, not just with us cleaning and cleansing the data, there's also challenges with us collecting the data because of these communication issues. So the CEO and the CIO at the time, Mark Norwell and Josh Bavell, respectively, these guys had an idea that they wanted to transform Perenti into a data-driven company, and they knew that they had to get a better data platform to kick that off. So instead of going whole hog, we're gonna just grab one off the shelf and roll it out there, they said, what is fit for purpose for Perenti? Because we are a different company and we don't own all of the data that we use every day, they said, let's start a BI program up and let's do two things first off. The first thing that we're going to do is we're going to start a data governance working group. So key people in the business, SMEs, respectives in their areas. So it might be the planned maintenance guys, it might be the operational team. In BTP's case, it was their operational manager, and got them together and said, holistically, what are the things that we need to work on first? And things came out, which you guys would expect. We need to make sure our sites are named correctly. We need to make sure our equipment is correct across all of our systems. So whether we're calling a truck L300 in one system and L300Z in another system, how do we map those together? Master Data Services was brought on, and that gave us a starting point for where we were going to head in our Lakehouse migration journey, right? The second thing that they did was they said, we want to make sure that the technical landscape is fit for purpose for Perenti as a global company. So we sat down with our architecture group, and nothing would surprise you on this diagram. It's a pretty bog standard cloud data architecture, right? We've got multiple sources on-prem, we've got multiple sources in the cloud. We bring that together, and then we move it through a layers of enrichment. I'll talk about Adobo and the layers of enrichment and how it's not your bronze, silver, gold standard for later on that we're using, but we then get that data out and we present it. And we present it through multiple presentation layers. This is just simplified it down to Power BI, but we've got some legacy ClickSense, we've got some Spotfire, we've got a couple of other ones. And then we also share that data with external clients, not just our mining contractor owners. So when they say, okay, tell us about the number of safety incidents on site, so we can share that information out from the platform itself, but also with Adobo and partners as well. But the key point of this is this architecture involved the architecture group, it involved the network group, it involved the infrastructure group. So now our little data team is not just small, it's starting to grow bigger and bigger as part of this process. And another thing that Mark and Josh were very keen on is making sure that we picked the architecture that was fit for purpose. So we didn't come up with this on our own with the architects. We went out to partners and said, can you do a quick POC for us, a study for us, and make sure that the architecture we're building is fit for purpose? Now, it just turns out one of the guys who helped work on that externally is here in the audience, so thanks for coming along, Ian. But once we had that study done, it was easy for us to go back to the board and say, this is the plan that we're going to put in place. Let's move forward with this architecture and start building it, right? So, as part of that architecture, actually I'll go back. This doesn't have a, maybe it does, look at that. As part of this architecture, we put together a Perenti data ingestion framework. So you would have seen lots of these, a meta-driven data ingestion framework, but we wanted to make sure that it went from end to end. So we started building slices, and we built 4 patterns of those slices. One was a CDC pattern, one was an ingest relational model pattern where we had good data sources that had last updated time or created time in them. We had a flat file ingestion pattern, and we had an API ingestion pattern. Now, the API ingestion pattern, for the most part, is us recoding it each time for each API, because it might be JSON, it might be a RESTful API. We have to do some code in there. But all of those patterns connect to a data source and are configured through metadata, but then push the data up to or land the data in the first landing area of our lake in a snappy Parquet file format, and they're all the same after that. So we made sure that we standardized on our ingestion patterns, but then we also knew we needed to support this platform moving forward. So we built 2 things up front. One was a concurrency dashboard, which is the one at the top. So that allows us to say, as we enrich the data going through its various layers, how long does it take to get there? So we snapshot the data we put a timestamp on the data as it moves through those layers, and that allows us to show the timeliness of data as it's getting processed. The second thing we did is we used a series of hashes to be able to track the accuracy of our data as we enrich it. Because the last thing we wanted to do is, once we have a full data platform like this with now up to 200 terabytes, we had 800 terabytes for a bit, but that's a different story. But now 200 terabytes worth of data, which is not big, but when someone says, is that data on my report correct? We can use these support dashboards to go, it's exactly what's in source. We don't have to go back through the manual hops of debugging all these things. We can look at the dashboard and say, it's the same as source, go change it in source, right? So that's a massive time saver for us. And we encountered some problems as we went to do this, because we were new to Databricks, right? So we used autoloader for this process, and autoloader running in continuous mode scaled up for these things. So that's well and good if you have the money to look after that. We were making sure that we were not being frugal, but right-sized for this platform. We have an ERP on all of those 60 sites, one ERP on those 60 sites. Each ERP has 800 tables. At the end of the shift, everyone is madly changing data in those 800 tables and going go. So in a time zone, what would happen is we would see these rolling, growing periods where data changed and our autoloader expanded and our costs went up, right? So we came up with a way to deal with that. We put it in non-continuous mode, file notification mode, and trigger once. So we whack it on a queue, and then we process that through there. What did that do? That made these concurrency dashboards slide up a little bit during those peak times, but nowhere near enough to warrant any issues with the site. So that was our base platform, and the guys were busy building that whilst the data governance team was still working, and we were coming up with use cases for what we needed to work on. Now, one of the first use cases that we worked on was the LMS, so the the training report. So the training report's very important for our African business because we're operating in an African region. We have to make sure that we're keeping the local employees trained, up to date, and getting new skills on a daily basis, well, as part of their work, but then on a monthly basis. And as they start new jobs, they can get trained up in those new skill sets, and then we need to report to the government that we're doing that to make sure that we can operate a mine site there. And up till this point, we'd only been doing this reporting out of Botswana. They wanted to expand that across every site in Africa, and that's where predominantly most of our sites are, right? The standard on-prem architecture to be able to do this wouldn't cope with the amount of data that we needed to flow through and then report on out of Power BI. So instead of reinventing the wheel, the first part of us building this Lakehouse was saying, how can we get access to more data really quickly? And Databricks notebooks really helped us with that. So we took our existing on-prem SQL patterns for just one site, and we moved them up to the cloud into a notebook, and we put a little bit of Python at the start to make sure that we tested our data and that there was no duplicates and those fun things. And then we ran exactly the same queries up in the cloud with some slightly different syntax, and then we did some tests at the end and enriched that the same way our on-prem would have, and just went through a workflow. This allowed us to process every site far quicker than we could have done on-prem, and we could use exactly the same presentation layer as we had before. We just added sites to it, so there was no work on that. What the business expected to be a 3-month turnaround to get all these things happening, we were able to do that in 1 month, right? So that was the first pass of us going down the Lakehouse architecture of enriching that, taking what we had on-prem, putting it up there. There was a couple of other use cases that we came up with, which we did the same thing, but we knew that wouldn't be sustainable in the future. So we spoke about earlier being able to support this platform and being able to have the right skills in case we have some people leave the team, get new people on. We realised that if we go down the route of having to maintain the same SQL that we had before, things would be unmaintainable once we expanded, once we growed, and we needed a way to standardise our development of enrichment, not just the complete DevOps delivery of these things and the governance over the release patterns, right? So we went down the route of DBT, and this is what we're starting to do now. And you have to remember, this is in the period of a year of us doing this, so it's quite rapid in terms of our development of getting off the on-prem instances and up to the cloud. So recently we started using DBT.
On the previous slide, you had a lesson learned.
Lesson learned on that one is a very simple one. In a SQL environment, a null varchar is slightly different to when you're in the cloud and you've got a snappy Parquet file format and you're getting nulls out. It just doesn't return any value, not a null, right? So we did have to do some refactoring of the SQL code as we went through that. But again, that was part of the testing at the front and the end of those blocks, right? But thank you for pulling me up on that. And if anyone does want to ask questions, stick your hand up.
Yes, please raise your hand and I'll go over there.
Cool.
Thank you.
And if I'm talking too fast, let me know. So we're going down the route of DBT. So does anyone here exposed to DBT before? Yep. So you guys understand that it allows us to, out of GitHub, or out of Git, store our code repository in there, standardize the way we enrich our data sets. Now this is really important, and I'll tell you why. A couple of use cases that we have out of the business is the sustainability team want to know what is our, because ESG is such an important part of the mining sector, they want to know what our fuel usage is to determine what our greenhouse gas emissions are, right? The health and safety team want to make sure that they know how many incidents we're having on site accurately per hours that we've been operating and hours that we haven't been operating. HR want to know where people are on site and what they're doing so that they can track these people and know that they're doing the right things at the right time. The planned maintenance guys want to know how often the machinery is being run and whether it's coming up to their boilerplate maintenance so that they can A, do predictive maintenance on it, or B, just say it's time for service, let's get it up there. And the operational team want to know how long were we operating per day, did we hit our tons per hours that we needed to deliver? So that's 1, 2, 3, 4, 5 different use cases. And that might be easy to tell on a single mine site. But when you have different systems capturing engine hours for all these different mine sites and you want to find out on a regional level, on a state level, or on a country level and global level, you're now talking about massive amounts of data, all that store engine hours in it, which is a key component for calculating any of those things, that we need to be able to accurately drill up and say that is the right value across all of the sites, right? So if we did that in SQL, we'd get something wrong. How do we standardize that pattern of enrichment moving forward? And that's why we started using the YAML and the Ginger in DBT and put that in our deployment processes. And this allows us to say, okay, out of the key sources, where is the engine hours coming from? And it might be different for the reflex source, or it might be different for a plod track source. We just change that ingestion pattern for those to make sure we're getting the right values. And then it's the same code that enriches it all the way through to get it out to all of those different use cases, right? So it really allows us to standardize that and also standardize the support on those things. The other cool thing about DBT is once we've got the calculations in from our BAs that says this is how you calculate these things, we can cut and paste that calculation, put it into the code and into the YAML, and then it generates us a data catalog out the back end. And it shows us data lineage. Now, it doesn't show us the active usage for like Unity Catalog, and that's something that we're bringing on. It's something that wasn't ready whilst we were doing this. It is now. So that's our next step for engaging that. We also want to engage Unity Catalog so that we can do all of the cool features that we saw at the keynote speech today. So the Lakehouse IQ and the LLM information, that's something that everyone's asking about at the moment. But that's been a game changer for us. And the data catalog that it spits out can also then share with our end users what data is available for them to use in their reports and how they can track that data through. So that's the standard stuff of moving from on-prem to a lakehouse. There's also other stuff that we do. So I was talking to you about Adobo at the start, our data science company. They have a couple of products. So they're they're a company inside of our company, and they do data science activities for other mining companies and other industries as well, other verticals as well, so health, government, those types of things. But one of their tools is MPN. So MPN is a machine learning tool. Very similar to what you would, the similar functionality that you would use on any other machine learning tool. They've got their own product called Acumen, which drives this in the back end. But basically it allows them to do predictions, standardized predictions on those things of how your underground performance is going to go. Are you going to hit your tons that you need for the year? All of those fun things. And it does it in the standard data science way of taking in a large set of data, neural network, pushing it through. Here's what we predict your outcome to be. Suite of reports over the top of it, all that's fun stuff. They couldn't get access to the data from all the individual sites until our data platform, which we call PACE, came along. What they had to do was they had to fly out to site with a USB drive, take a backup of all the data sources, fly back, plug it in, and then get on the call and hope the comms are still up, talk to the SMEs over there and say, how is all this stuff laid out, and drive their data science capability through that. So by being able to create one simple share, and we're using Delta Share at the moment, with Adobo, they can get a copy of that data and leverage that with this application like that, as opposed to a 7-day turnaround, which was what they were having to do. And that was good of them for that tool, but they also have another tool called Gemini that I want to talk to you about, which is this one. And it's a mine simulation tool, so it's slightly different to a predictive analytics tool. This allows you to simulate what's going to happen in your mine site. And the guys at Adobo are pretty smart cookies. They realized that the way that they were going to solve this problem was through agent-based modeling. Now, agent-based modeling was new to me when I found out what they were doing it, and it might be something that you guys don't know about, but the idea is you're using exactly the same data set that you would for your predictive analytics, but you're creating agents in your business. So an agent might be a truck, an agent might be the road, an agent might be a downhill decline, an agent might be an underground pathway, right? The reason why they're called agents and the reason why that type of modeling needs to be done to do the simulations is because it's a complex problem. So there's complicated problems and complex problems. Complicated is like building a bridge or building a house. Complex problems is when you start involving the human aspect of it, the driver, the machine operator, the health and safety regulators, all of those sort of things. They're separate agents and you need to deal with it differently to be able to run it in a simulation. Now, Adobo didn't have the capability to build an agent-based model, so they went out and found the people who did. So they went and spoke to Professor Miller in Austria, who said, I'm happy to help, she's an expert in those things, but I don't have the time right now. So they went to another guy named Ross Hammond in St. Louis, and Ross Hammond is the world leader on agent-based modeling, and he sat him down for a week and said, this is how you do it. So they went away and built it, and they built it in a 2D environment. So basically what it allowed you to do was say, here is our mine site, we can look at where all the trucks are moving, what happens if we add another truck into the mix? And that was all well and good, but most of our mine sites that they wanted to do these simulations on were underground. So it was all well and good to say, add another truck in, but they couldn't visualize the outcome of those simulations. So they started coming up with a pilot to engage with Perenti operated mines to say, we want to take our agent-based modeling and we want to drive it into 3D simulation. So they drew what an underground mine looked like, and this is the actual operating tool that they use to track information on site, and they said, can we export the 3D model out of that? They went, yes, you can export the 3D model out of that. So they ran a little POC, and I've got a little video here where they wanted to see trucks moving underground, and you can see that little guy going up there, and in about 2 seconds there's another one, and this is just the POC of that. This is the first stage of where they're up to on these things. And once they actually got uni students to do this POC, and the thing about this is to track these trucks moving underground, there's no Wi-Fi signal there, right? So what they had to use was the same data that we use for engine hours and machine planned maintenance is the RPMs of the trucks, and you can see that doing here. So the RPMs, it's the same data, and once the truck entered the downhill decline, underground decline, they then used RPM and the speed of the vehicle to track it through the mine site, right? And they said, that's a good enough POC, let's start productionizing it. So they went and got Unity Catalog and started building proper models, 3D gaming engine models of this application. And then they started building the trucks inside of it. So now you can take your mine operators and say, let's see what your mine is actually doing remotely and put a simulation of what's happening underground, can improve performance of operations and also help improve safety so that they understand how the vehicles are moving through their operation. But the other thing that they can do is visualize how these things are happening. So they did this for a lithium mine, and they said, this lithium mine has exactly the same type of trucks that one of our mine sites has. So this is for a competitor, one of our mine sites has. They trained the agent-based models on our data, so they knew how the trucks would operate. They had to update it for the people on site, so they did a quick retrain on site to do that. And then they ran the simulations to say, are we going to hit our targets for the year? What they found out was adding more trucks wasn't going to fix that problem from the simulation, and it was clear to see through the 3D representation of that. So they quantified that the maximum productivity of boggers, moving ore from productions of the stope, and the ore passes were the issue. So they built faster loaders, and they added another primary crusher on the end, and that increased their throughput so that they could hit the targets for the year. So all of that is running on exactly the same data that is running our operational reports. It's running on the exact same data that's running some of our integrations, and it's all running on the exact same PACE platform together. That was 100% not able to do on the previous architecture. So Lakehouse really got us where we needed to go in terms of some of these new capabilities. So with that in mind, let's do a quick wrap up. What did moving to the Lakehouse give us? Well, it gave us all the capabilities that we had before. We had to walk and chew gum at the same time, but we also didn't want to go backwards with these new capabilities, and we needed to make sure that the business still ran. And we were able to do that. It gave us new capabilities that we didn't have. You saw the predictive analytics we were doing before. We can now share data easier between our customers and internally, and we can share more data. It, for the most part, is cheaper than what we had before. We consolidated 23 SQL instances that we were doing before. We decommissioned them. That with the actual hardware that was on there and the data services costs, the data center costs that was on top of that, we actually came out year on year cheaper with a Lakehouse platform than what we had previously. We can process more data in our reporting, so greater granularity and understanding of what is happening in the business in a closer to near real time for the guys out on site. The example here is one of the major operational reports was previously running on 800,000 rows worth of data. As soon as we went live with the first pass, that SQL lift to the cloud that you saw running in notebooks, we're able to do that up to 14 million rows. Now with DBT and us processing all of that together to basically bring all that data sets down to small stuff that they can report on, we're going over 80 million rows worth of data, right? So their granularity on what they can drive insights and value from is greatly increased. And because we have we've stopped access data to source sites, data on site at source, we're now getting it all from the lake. We've massively reduced our network traffic, increased comms, and created more sustainability for operations on site. So the guys can automate their reports better, they can have more time doing their work, and the comms stay up longer for them to be able to do those things. And that is our full migration to a Lakehouse. Those are the challenges that we faced. I've got 5 minutes for questions if anyone's got them. Hold on. I think we've got a microphone. I can hear them. I think it's so that the other people can hear.
First of all, I'm sorry to hear about your rat problem. I'm glad that the problem has been resolved.
Not a problem anymore.
So in this migration, right, all of the things combined, what is the total size of the data that we migrated? That's number one question. And
Yep.
then from the Lakehouse standpoint, can you highlight the top two problems, not related to industry, but in general, what you faced in terms of Lakehouse?
The type 2?
Top two problems, couple of problems.
A couple of problems?
Yeah.
Yep. So talk about the data size. Originally, we were using Delta Live tables and the history on those to maintain a history of data changing through our platform, right? And when we were using that, we blew out to 800 terabytes worth of data in our Lakehouse. By putting type 2 solution into our ingestion patterns, we now capture the delta in Delta tables. But that's now manually tracked, so we've been able to reduce the size of our lake down to about 200 terabytes, but that's growing about 50 gigabytes a day of data changing. So we're getting lots and lots of data coming in, and we're sharing a lot of that data out. So, but we expect that to expand as we make more acquisitions, as we grow as a company, and we've recently just made another acquisition, another 2,000 people joining the team. We expect that to balloon out, right? And some of the challenges or some things that went wrong?
Yeah, with respect to Lakehouse. Because we have been listening to a lot of the pros so far. Wanted to hear about some of the cons that you faced.
The cons? Yep. So an example was the size by using the Delta history and the way that was managed at the time. That blew out our costs for storage, right? So we had to then go and implement a type 2 transformation as we get the ingestions in to bring that size down. That's one example. Another example was the actual sharing out the end, right? So we spoke about the metadata-driven model where we say, here's our source table and we want the raw data exposed to the end user. We actually use Azure Synapse as a Synapse serverless on the end to expose it like it would be any table on source. So they can connect to it with an ODBC connector or they can connect to it with Power BI, right? One of the things that we face is one of our very heavily used presentation layers is ClickSense. ClickSense, up until very recently, wouldn't connect through OAuth to our SQL Synapse instance. So how do we correctly and follow the data governance processes and the security processes, connect this into our architecture moving forward? That one we solved by calling up ClickSense and saying, this isn't going to work, you guys need to come up with a new connector. They came up with something compliant and we moved that through, right? One more example, there's many lessons learned on how we enrich the data moving forward in our Lakehouse. So I spoke about not using bronze, silver, and gold as a pattern of enrichment. What we really did was says, here's some super users, you get access to the raw data, and you can do whatever you want. Adobo needs a copy of the raw data, some enrichment, so that they can make quick decisions off of those things in their analytics and in their predictive analytics. And then we have a couple more layers of enrichment moving forward, and you can see that in this. It's 1, 2, 3, 4, 5, 6, 7 in terms of hops of that data moving forward and getting loaded out. It took us a while to understand how that was going to look and be fit for purpose for Perenti. So we had a couple of cracks at it. It took us about 2 months to get it right. Yeah, but we always made sure we delivered the value first in some form, and then went back and fixed the process in the back end. Yep.
Thank you.
No problems.
Yeah, thank you. Did you actually migrate any of the SQL business logic out of your legacy to the Lakehouse?
100%.
Right.
That was our first pass.
Okay. And how did you do that? Did you automate that?
We didn't automate it. We looked at automating it. We could have. So all of our code on-prem was in SSIS.
Yeah.
We could have written some scripts that went through the SSIS database, pulled out the stored procs. We knew what the lineage was, sorry, execution pattern for those things, and then regenerated it up in the cloud. But for the 3 use cases that we had to do, and knowing that we were going to the DBT platform. We said, leave some of these things in legacy. So our corporate finance warehouse is still on-prem. That's the next thing to move up. We said, leave that. Here's the big workloads that we need to use up. So take and lift that SQL capability up to the notebooks. And we did that manually because the value of writing something to automate that wasn't going to be there because we knew we were going to go down the DBT track to standardize on those.
Right, okay, understood. Thank you.
I think there was a final one over. Oh, go there, and then there. Yeah, we got time. Thank you for coming, by the way.
I was just wondering what is the size of your data lake team, and what skills did they already have, or did they need to acquire in order to do this over this time period?
Yep. Great question. And I probably should have mentioned it earlier. So once we had the partner come in and show us what we needed to build, the team that was maintaining the on-prem solution, we had 5 in the data team and 4 in the report writing team. It was a total of 9. We realized and none of them had any cloud capability, right? So we hired 3 or 4 more technical cloud specialists who already had the capability. And then we hired a bunch of BAs and PMs to help manage the transition of a program of work over multiple years. Yeah? So the team actually ballooned out to about 24 people whilst the program was on and we were gathering requirements and doing all that. And then we made sure that we engaged with our local partner in Databricks, which is Jürgen and Ellie and Vimal. So they're the solution architects. And we said, how do we train up in this? Now, we had hired some unicorns. Luckily enough, we were able to get them. So they were able to do some hands-on training, but also with the help of Databricks and some certifications and some exams. We then put our guys through, and I make it a point in the team that you will work 36 hours for the week and you've got 4 hours to train, right? And the training needed to be for this: Azure Fundamentals, Azure Data Fundamentals, DP203, right? And I think DP203 is being deprecated now and it's whatever the next one is. But those 3 things so that they could understand how this all worked. And once we got to DBT, we had to go back to the well because they needed to learn Ginger mostly. Everyone had pretty much exposure to YAML by that point. But it 100% was a staged approach. We said, you're doing the key training next, you're doing it this, because we could see the workloads that we were lifting to the cloud, that we were deprecating on-prem, and we had to shift our capability as the features arrived in the cloud platform. We still have guys that need the legacy capability to maintain our replication and that on-prem solution, but that's SSIS, CDC, some InfoSphere capability. Most of the teams already got that, and we share that around, but the cloud capability, massive shout out to Databricks and Microsoft locally, who really helped us ramp that up, and also the smart guys on the team that helped train on the day. No props.
I got it. So your data architecture looks eerily similar to my company's, so it's nice to see that familiarity. But I noticed you use Synapse as that kind of in-between connector between your tables in your data lake versus your BI tool, Power BI.
Yep.
And I was wondering, with the release of the serverless SQL warehouses, you were waiting for this, if there are plans to replace Synapse with that, or if you've analyzed the pros and cons of each.
Let's ask my local partner, do we have plans to change over to those things?
Okay, good.
So through this whole process, like I said, we have a couple of unicorns. Those 2 guys, and luckily we have the right partnering with Databricks, that we have exposure to the product team, and we've been providing feedback and saying, this is great, this works, this doesn't work in our case, can we change this? So things like Unity Catalog being able to deal with nested AD groups, right? Now that's there. That was our roadblock for us going down the Unity Catalog route, right? SQL Serverless in Databricks. We wanted to use it. It wasn't there when we started building this, so we had to go with Synapse to give the look and feel of standardized tables. 100% we want to move that back. Less moving parts, means it's easy to maintain going forward. It's going to be a monster change management piece, however, because here's our endpoints that all our reports change to. We come up with a new endpoint that looks exactly the same, so it's easy to change, so we're going to have to figure out some way to automate that, but that's okay. We'll do that.